Hello, welcome to the second part of this series of this tutorial where we are building 1D HEC-RAS model. In this second part, we are basically going to be diving into the details of how we can set up the 1D model. The first thing we need to do is to prepare our folders. It's very important. We're going to also cover how to download the digital elevation model or digital terrain model. Then we are going to look at how to inspect our digital elevation model. Make sure the digital elevation model we've extracted it okay, have the right cell and the right projections. To begin, we need to find a location and create a model. This is the model structure to which I adopted. It's called a folder 1 to folder 7 for a 1D model. Basically, we need the hydrology. Here we are going to save the stream flows, the peak flows we have extracted, which we are going to cover later in the section. We are also going to save out our projection file. So for example, here I have a state plane projection. The HEC-RAS is always fine with state plane projection. If you have a project specific projection, you may need to uh, learn how to convert it to a state plane projection. We also have the shapefile, so information about the bridge. If we have the bridge line works or measurement, we can also be able to draw those lines ourselves. We can bring those shapefiles here. Those shapefiles we are going to import it into HEC-RAS. So HEC-RAS will be able to guide us on how we want to place our lines. We have a folder for log file. When we run our model, sometimes we have some complaints from the HEC-RAS model. We want to be able to fix this problem. We want to track them. So we'll save them in the log file and we'll come back to look at them. We have the result folder. We're going to export our tables that shows water surface elevations and critical elevations. We're going to save it as PDF. We're also going to save any profile plot like PNG plot as a PDF here. We have a folder that I have a terrain file. For this particular project, I have extracted the whole terrain, so I'll put the terrain in the terrain folder. We have a folder for the model, so here we are going to create our model. We'll put it here and we'll be able to tell our HEC-RAS where to look. So this is how the folder structure is being set up. Now to be able to extract the terrain of choice, for example, we will be able to go to a site. I linked it here. It's called opentopography.org. When you go to this site, you need to create your user account and user account to access the terrain files. So to get the terrain files, I have linked the folder here, and this is the link to the terrain file. So this is how the open topography where you can extract the terrain file. And if you click on the link to be able to access it, you need to sign in to have an account. So I'm not going to create an account in this video as I already have an account and I have already extracted the terrain that I want to use like I showed there. So you have high resolution terrain, you have a 1 meter terrain, 2 meter terrain. We also have the 30 meters terrain. We have the 30 meter SRTM data that it can be getting, which is the SRTM GL1 data. To extract the terrain file, as the example is the 30 meters, you need to go in here and click on the GL1 data. When you click on the link, you are going to find your location of interest. I'm looking at somewhere in West Virginia. West Virginia is of interest to me. So I'm going to go to West Virginia pretty quick and I'm going to draw my area of interest in West Virginia and proceed with this process. So let's find West Virginia. So we're going to zoom down here. We see West Virginia here and I want to extract somewhere around here. My river could be should be somewhere around here. So I'm going to click on select region and I'm going to do this and I'll define my area of interest. And the next thing I do, you see that we'll see that the minimum and the X minimum, the Y minimum, and the X max and Y max, which is the bounding box, is selected. If you have your own bounding box, you know it, you can be able to compute, enter manually, and extract them. The next thing is we want to get the data as a GeoTIFF, so we can go down here. If you want it as an ASCII file, you can download ASCII file, but you need to be able to use ArcGIS or some other format, data format reader to read. You can download the data as an image, but we want to leave it as GeoTIFF. In addition to the elevation, you can also extract the hue shade, the color relief, the color hue shade, the slope, the aspect, and the roughness. These are also very crucial if you want to do other analysis, but we are not going to do that. We all just need the elevation right now. To download the data, you need to enter your email. When you enter the email, then you can submit, and they're going to send you the link and you download it. When you download it, you have to open it in ArcGIS and do the inspection. So here is my own data. I've downloaded this data set and I can get 1 meter data. To get a 1 meter data or less, you need to be able to use LiDAR. And there are some LiDAR data you can also download from the site. If you go back, you can see some information on LiDAR. So we have, let's see, you will have some high resolution, and you can find some LiDAR data here that is high resolution, and you can find specific to your region or location, and when you get it, you just go through the link and get the rest of the data. But I am not going to spend time on that. This is self-explanatory process, just the way we went through the 30-meter data. This is the data that I got from the site. It's the LiDAR data. The LiDAR data has some problems. As we can see, we have some building footprint that we are going to be correcting because we need the S10 to put our cross sections. So in the next couple of videos, we are going to do some terrain modification and we're going to clean it. As we can see, we have this is the bridge structure that we have from field. So it means we are going to insert our bridge here and here, and we need to put our cross sections to go through this channel here. And to do that, we need to clean up this terrain. Now, one more thing that needs to be done is to be able to do some fixes. We need to do some raster information analysis. We need to check to see that we have this right coordinate system. And to do that, we need to go back to GIS. We need to go to the DTM properties. We need to click on the DTM properties, and we need to hit on raster information. And in the raster information, we can see that information is coded. We have this DM is a 0.1 meters, which is very high resolution, and so we are good with that. So with that, we can proceed with the model. And what we need to do now is to go back and make sure that we have our folders, the DEM and the folders. So we need to put the terrain file in the DEM and we'll have it here. So we're going to use this terrain file to create the DEM, rather to create the RAS terrain model. And from there we can continue with the model. So in the next video, we are going to look into how we can do that. But first we need to download the HEC-RAS software and we need to be able to start a project. So in the next video, we are going to do that. So I will see you in the next video.